questions from homework. Question. You might give me this answer and you might say, in order to solve it, I had to subtract 300 from both sides in order to solve that, okay? So as you look at the rest of this page, questions that I could look at or go over or talk about, this is on page 62. And again, what's always helpful for me is that when I'm looking on this, so page 60, like if we're looking at 18, right? So on page 60, I might look at number 18. I had a few people that were telling me ones with pi, like anything equations with pi that they struggled with. Well, this was the number 18 that was on page 60. And some of you have big question marks, like when you turn your homework in, the picture of it. You got to ask on those, and you don't want to leave them as question marks. You're like, well, Mrs. Thompson, if you want to come to the Zoom, by the way, I know my Zoom this morning wasn't working, and hopefully they have it working now. So I look at this question 18. It said 3AB minus 2BC equals 12, and we were solving for C. Now, if you haven't done this one, do it, right? If you haven't done this one, turning back to page 60, make sure you have it done. So first off, I need to get C by itself, and the first thing that I notice is that C is with this term. That's what I have to get all alone. And this is a minus 2 in front of it, or plus a negative. So the first question is, how do I get rid of 3AB? I get rid of 3AB by subtracting 3AB on both sides of my equal sign. They are not like terms, they will not combine. I'm going to leave this as 12 minus 3AB. And on this side, the biggest mistake is people will put 2BC. And you just got to watch that negative. So those positive and negatives, really those little tiny details are what throw people off a lot of times. So at this point, we have our problem. And I am trying to get C by itself. Well, this is 2, negative 2 times B times C. So I'm going to divide it by both negative 2 and B for each problem. Well, when I do that, I'm left with C, because this is the same as 1 over 1. And I'm going to take 12 and divide it by negative 2. Negative 6 over B. And I'm going to take, negative divided by negative, well, that's a plus. And I'm going to keep 3. I'm going to put 2 in the denominator. I'm going to have A up here because B over B is the same as 1. So if I'm looking at simplest form as I'm doing, okay? The problem was absolute value of y plus 4 is greater than 12. So the first thing you want to look at in the problem is our absolute value totally by itself? Yes. We're going to do the positive. Now, here, we are going to be thinking of keeping this both inequality and number either the same, or we're going to go opposite, okay? So the same is the positive. That's my positive. It keeps everything the same. I put y plus 4 greater than 12. If I am solving this, what do you think as you look at this for solving? As I take a look at this, what do you think, Dustin? What would I do? Just to finish solving this one. Subtract 4, right? We're almost done with the problem. We're like, yes. And Hayden, we get y is greater than 8. And we're kind of done. But then we go over to this opposite side. This is the negative, or if you want to think of it, I sometimes like to think of it as the opposite. So the opposite is saying, oh, we don't change this. This stays exactly the same. What we take the opposite of is this part back here. So instead of greater, it's now going to be less. Instead of 12, it's going to be negative 12. And did you already have 12b done that you're not doing this with us? Okay, we're in your workbook on this one. So I'm looking at this, and now I'm solving it the same way, right? So if I'm looking at solving this, what am I going to be looking at doing, Addison? Minusing 4. But do you see that we get very different answers? Here we're going to have y is less than negative 16. and greater than 8. And in the video, they talk about if this is an and problem, where the two arrows go together, or an or problem where they go apart. If you think of graphing this on a number line, right, here's 0, here's 8, negative 16 is here, right? Now, they're not going to always ask you to graph, but if you think about this problem and you're trying to decide, is it from the compound in A11 an and where they go together, or an or where they go apart? This says graph y is greater than 8. We've done that in our homework. Open circle at 8 doesn't include 8, going greater. The other part says y is less than 16. Over here, open circle. Do they have anything in common? This would be an or problem because they have nothing that intersects. If the two end up going over each other, then it's an and. And when, in the video, we kind of talked 50. But we also think that you have to be at least 18 to vote, right? So should it be a greater or equal or lesser equal? If we are setting this one up, we probably should go with greater or equal. And I prefer to put the numbers last. Put your variables first, right? So if I'm looking at the problem, I might start number 15 on my paper and go, oh, B stands for speed. Someone said, well, can I use S instead of B? Sure. Can you use X, M, K, whatever you'd like, okay? So, 5 times B, B stands for my speed, is greater or equal to 250 miles. I'm going to solve it. So on the test, what I might ask you is, you've written this equation, and I might say, give me your solution and explain how you solved it. So you would tell me, oh, the speed has to be greater or equal to 50 miles per hour. That'd be your answer. And your reason that you might give me, because a big part of this test is not just solving it, it's justifying the steps. That's why some of you, when you submitted your pictures and you just have the answer, I'm like, hey, it doesn't cut it, I need your work. So then you'd say, oh, in order to solve it, you had to divide by 5 on both sides, okay? 16 we're not going to do, so you don't have another story problem on this one, so we're going to go to 17. So again, when you look at 17 on the test, this might be the question. If you would please write number 17 down on your paper. We're going to do this one together. It's 3 times parenthesis k minus 5 plus 9k. The one question I always have students ask me is, if it's like an S or a T, can I use X or Y, or can I use a different variable instead? Because my X looks like, my S looks like a 5, okay? So, first step when we take a look at this one. I'm looking at the problem and I'm thinking 3 times parentheses. Now, I have some people that don't like to write this down, but on the test I'd be looking for the explanation. So Hayden, what could you tell me is our first step in doing this? Take 3 times everything in parentheses. What property is that called when you take 3 times the stuff in parentheses when it's out in front? Anyone remember that name? You have to justify steps for the test. This is the what property when you take 3 times it, getting rid of the parentheses, starts with a D? Distributive, thank you. So your explanation that you might tell me is you wrote the equation, and then your first explanation might be I used the distributive property and got rid of the parenthesis, right? Or I multiplied 3 by everything in the parentheses. 3k minus 15 equals 9k. Next step. We have to do what, Lily, with the terms on this side, the 3k and 9k? We have to add them. And we notice it's a positive 3k and 9k. Now, the biggest mistake, again, that I see people make is they'll put a minus 3k and a minus 3k. They're on the same side of the equal sign. We are combining those. So if I'm looking at that, I get 12k minus 15. So again, your step might be that you've done this and on the test you're explaining. So the explanation might be, and there's going to be an opportunity for you to write like with a mouse, but it's kind of hard like on your screen, right, to write with a mouse. So it might be easier to explain it. It also might be easier for you to type it in because you're going to see like this math type that has equations and all this stuff. Or you could just say to me, I added like terms and 3 plus 9k gives me 12k minus 15 as I'm looking at that. Okay? So I'm going to continue. But, Kian, what are you going to do next to get 12K by itself? I don't want this minus 15. Add 15. Yeah, don't make it hard. It's not like I'm not trying to trick or anything. So we are looking at this and we're going to say, okay, I am looking at adding 15 on both sides, right? So I add 15 to both sides and I get my new equation. And I have 12K is greater or equal to 12. I'm almost done solving it. I'm going to divide by 12. And if I would have divided and say this was a negative over here, you never switch the inequality unless you multiply or divide by negative. And so in this case, my answer would be K is greater or equal to 1. Are there quite a few steps that I either want you on the test to explain to me or to show this work somehow? Yes. I do not want to go from here at the beginning to the very end without some explanation of how you're doing this. So when you're looking at the problems, you'll have this original on the test. You'll be explaining to me as you're doing those. So as we look at this assignment, I'm going to leave this up in class. If you're doing 19 next, you might write down the problem to show your work as you're starting that one. And as many of these that I can help you with in class, I would like to. When you get here, you're going to notice that you're going to have no solution or all real number solutions, right? It's either a true statement or false. That's what determines if it is. And again, some of these. Now, the biggest mistake I'll have some people make, I had someone on one of the assignments they turned in submit a picture, and it was when you did the literal equations. And they said, solve this equation for X or Y or whatever. And they told me it was no solution. Well, that's not even possible. The literal equations, you're just getting, it's just variable manipulation. It's just knowing, can you switch things around? There's always going to be a solution. Is there a solution when you're doing these? Maybe not. Now, the next thing on the test I might ask you with this problem is I might say, you know what? You just got this answer. Give me an example, Anna, of something. Give me I need 3 numbers that are going to be a solution. So we got this, K is greater or equal to 1. Can you give me a number? 3. So she'd put down, so she solved it and got this. There's infinitely many answers, right? We know that. K is greater or equal to 1. She gave me 3. Another one, why it would be 1. And now I want to be creative. Someone got a creative answer for my last value. You already answered, so I got to get someone else to be creative for me. What else could I have? Or an answer that's going to make this true a number. I can do anything, right? Yep.
Infinity.
That's not a number. I need a number.
Pi.
I could have pi. Could I have 5 pi? Could I have 720.372? All of these numbers are greater than 1, right? So if you are asked to give a solution, give me 3 answers, right? This is saying that there is like infinitely many, right? 1.00001 is a solution, but so are all of these, right? So just being sure that you answer those questions. And like I said, I think we're going to have a practice one next week on before we begin. So before I just let you loose doing these questions, what?